Hi, I'm Fakul Hakim. Introduction. Robocar material technology is a career for autonomous vehicle enhancing safety, efficiency, and convenience. However, selecting a suitable material is essential for their durability and reliability as they navigate without human intervention. The problem statement is Robocar require materials with exceptional strength, durability, environmental resistance, safety, and cost effectiveness. To ensure their effectiveness and reliability, this material must withstand temperature fluctuation, UV exposure, and moisture, contribute to overall vehicle safety, and be economically viable for mass production. Why we choose the material? Epoxy resin and PVA solution are chosen for Robocar construction due to their complementary properties, offering robust structural support and environmental resistance while providing flexibility, biodegradability, and protective qualities, paving the way for autonomous vehicles.
My name is Anshava. I will give an explanation about our project. For the project overview, creation of a functional microbit Robocar focus on building a practical working robot car using the Microbit microcontroller for the small and programmable. The Robocar is designed to be compact and can be programmed to perform various tasks. For the capability to carry items, the Robocar include a feature to transport small items, demonstrating its practical utility. For the simplicity and versatility of Microbits, utilize the easy-to-use and flexibility Microbit microcontroller as the core component. For the functionality, for the navigate through different environments, the Robocar can be navigated through different environments by executing programs commands for moments. For the item transport, the Robocar has the ability to carry items at practical dimensions, showcasing potential real-world application in tasks like delivery or material handling. For the applications, for the education tools, the project serves as an accelerator introduced to robotic programming and electronics, making it ideal for education purposes. For the prototyping, it provides a foundation for future developments and customization, encourage experimental and innovations.
Assalamualaikum and good evening. My name is Muhammad Zudin bin Hashim. I will present about my part is the purpose of the Robocar. First, I will present about the Robocar. Firstly, about the chassis. The Robocar has a lightweight, possibly by plastic or the plate of the to hold all the components together. And then it appear to be steady enough to support the weight lift of the electronic and the basket about the attachment. And then we go to the wheel and motor. The vehicle used to have a large wheel likely driven by the DC motor for movement. And then it have a basket attachment. The last basket is purely attached to the chassis, suggesting the Robocar is designed to carry lightweighting load. And then we go to the multifunctional of this Robocar. The Robocar function to carrying a small load in the basket. And then the V-shape on the behind of the Robocar can be used to push the load also. That's all for me. Thank you.
So for material and method, first is preparing PVA solution. Preparing PVA solution to obtain 4 weight % PVA solution, 4 grams of PVA powder will be dissolved in 100 milliliters of distilled water at 80 degrees Celsius for 30 minutes while being continuously stirred on a hot plate. Step 2. Epoxy resin solution preparation. 30 grams of epoxy should be weighed and placed in a beaker. Mix the epoxy solution with 30 ml of the PVA solution from step 1. Include 10 grams of curing agent in the mixture of epoxy and PVA. After that, the mixture will be stirred until it is completely homogeneous. After that, the mixture has reached completely homogeneity. Allow it to settle and defrost. Second, preparation of epoxy resin solution. Epoxy weight 60 grams should be placed in a beaker. Mix the epoxy with 20 grams of the curing agent and stir until the mixture is completely uniform. After that, the mixture has reached complete homogeneity. Allow it to settle and defrost.
Hi, I will explain how our Microbit Robocar works. First, we set up the coding to enable the car to move using the remote control. By writing and implementing a program on the microcontroller powering the car, we establish a communication link between the vehicle and the handheld controller. This coding allows the user to use commands through the remote control, which are then translated into instructions that govern the car movement with the press of button or the manipulation of joystick on the controller, and then the function of our Microbit Robocar. As you can see in the video, one of the primary function of our Robocar is its capability to serve a carrier, enabling it to transport and deliver various items or payloads from one location to other.
Good day, Doctor. My name is Ruchna Nandakumar and my matrix number is J21A1080, and I'll be explaining about result of characterization. Firstly, visual inspection. Examining items visually is an essential part of the assessment process. These are some essential details regarding visual examination in the description of the materials. Firstly, the resin sample is transparent and hard. It was fully dried without any bubbles in it. As we look at the tensile test, to apply a force along its axis, a sample of the material is created. To bear the greatest stresses, the width of the sample is narrowed in the center. The tensile test determines a material's capacity to withstand stress. The test reveals the material's stiffness through Young modulus with an average of value 577.240 Newton per square millimeter, indicating consistent stiffness across the samples. The maximum stress the material can endure before failing, denoted as stress at peak, averages at 19.153 Newton per square millimeter, while the stress at break, which the material ultimately breaks, average slightly lower at 17.864 Newton per square millimeter. The material exhibits good ductility with an average elongation at break of 39.434 mm, showing significant stretch before failure. The low standard deviations and coefficients of variation across these parameters suggest reliable and consistent material properties. The confidence switch limits provide a statistical range ensuring the reliability of these values. Overall, the material demonstrates a balance of stiffness, strength and ductility crucial for applications requiring these mechanical properties. Finally, optical microscopy. With its comprehensive knowledge of the material's microstructure and structure property connections, it is frequently the initial step towards a successful material analysis. Firstly, Image 1, which is 5 times magnification. The resin sample's optical microscope picture shows a complicated texture surface with a range of grey and blue tones, which may indicate differing densities or thickness of the substances. Sporadic brilliant patches indicate regions where light interacts with the surface differently, maybe as a result of compositional changes like inconsistencies or contaminants. This textured pattern may provide details about the resin's internal structure, including filler distribution, fiber orientation, and degree of curing, all important variables that affect the material's mechanical qualities such as strength and flexibility. The second image, which is magnified 10 times, in comparison to the first shot, the surface looks smoother and less detailed at lower magnification. The broader surface features such overall homogeneity and bigger scale flaws or inclusions are visible in the wider perspective. At lower magnifications, significant faults that would not be seen at higher magnification can be identified as well as the general integrity of the structure. And finally, 20 times magnification. There are noticeable rough and gritty patterns on the surface, which is highly detailed. The picture appears to show a consistent dispersion of fillers or particles inside the resin. The existence of small lines of scratches may be a sign of the way the resin was applied or of any mechanical interaction that followed. With a closer look at the resin's microstructural makeup made possible by increased magnification, one may better appreciate the material's mechanical strength and bending flaws. Thank you.